So in this video, I'm going to talk about the last three types of reactions. So the first is a single replacement reaction. So a single replacement reaction is when you have a single element and it's going to replace an element in another compound. So the form, if you look at it, you have A would be the single element, and then you have a compound. And if A is a metal, it's going to replace the metal from this compound. So this would be an ionic compound, and remember we always list the metal first. So in that case, A would kick B out and steal C away to form a compound that was a combination of the metal A and the nonmetal C, and then the metal B would be all by itself. Now we can also have a nonmetallic replacement. So in this case, if you had D was a nonmetal and you had the same compound BC, D would replace the nonmetal, which is second in the compound. C would be kicked out and all by itself, and then B would hook up with D. So if you think of it in terms of this, so you have, so let's say like Joe and Sue went to the dance and Bill's there, and Sue realizes that Bill's a much better dancer. So Bill kicks Joe and steals Sue away, and so now Sue and Bill are together and Joe is all by his lonesome. Now another chemistry example of it is, let's say we have a lithium. Lithium is an alkaline metal, and it again is very reactive with water. So if we put lithium with water, it's going to kick the hydrogen out of the compound and steal the hydroxide away. So that's a little bit more complicated of an example. So lithium kicks out hydrogen, steals hydroxide, and hydrogen is left by himself. Now, if we were to look at a double replacement reaction is when we start with two ionic compounds, and when they come together, they're going to swap ions. So A and B are together, and C and D are together, and then they're going to swap. So A is the metal of this compound, so it's going to take the non-metal of this compound. So A will be with D. And then C is the metal, and it's going to take the non-metal here, and so it would be CB. So they swap partners. So if we talk about another social scenario here, let's say Joe and Mary and Josh and Sue go on a double date. So Joe and Mary go on the date, and Joe realizes that he likes Sue better, and Josh realizes that he likes Mary better, so they swap partners. So Joe gets together with Sue, and Josh gets together with Mary. Obviously, Josh is not very happy about this situation. But again, it's swapping partners, the idea of swapping partners. So if we look at it in terms of a chemical equation, we can see here we have silver and nitrate. So all of the nonmetals are highlighted, or the negative anions are highlighted in yellow, and the positive cation metals are in white. So here we have silver and nitrate, and we've got sodium and chloride, and so silver is going to take the chloride away, and sodium takes the nitrate away. So they swap partners. And remember, all of them here in this case are +1, so that's why the silver will go with the chlorine and the sodium will go with the nitrate without having to worry about any different subscripts over here. Now, another example, this one's a little bit more complicated, but potassium, you've got potassium and sulfate, and then barium and nitrate. So potassium is going to steal the nitrate. Well, potassium is a +1 and nitrate is a -1. So when we write potassium nitrate over here, we put just the 1-to-1 ratio. We use our formula writing rules, so KNO3. And then barium will go with sulfate, and they are each a +2. So again, they will be a 1-to-1 ratio over here. So we say BaSO4. And then we would have to go back and balance that equation. That's what this 2 is here for. It actually should be up here next to the K in order to balance that reaction. So that's another example of a double replacement. So then the last type of reaction that we're going to look at is a combustion reaction. So a combustion reaction is when you have some sort of fuel and you react it with oxygen and you form carbon dioxide and water. So a very common example of a combustion reaction is our Bunsen burners, right? So there is a gas that comes up and we ignite it so that it starts reacting with oxygen in the air and it burns, and the byproducts that come off of that are carbon dioxide and water. So fuels can be hydrocarbons or sometimes even carbohydrates. So a hydrocarbon is anything that is a combination of C's and H's. So in order to identify a combustion reaction, you're going to see a fuel, which is a combination of C's and H's, reacting with oxygen to form carbon dioxide and water. So this is always the form of a combustion reaction. Just because a reaction makes a loud noise or something lights on fire does not necessarily mean it's a combustion. It has to follow this form. And we'll do some examples of this and watch some videos of this type of reaction in the lab and in class.